Alright, so we're going to apply quadratics to word problems. So word problems are just a way to see if you can apply the math of quadratic equations and the graphs to a context or to a situation. So problems are usually about trajectory of a fallen or thrown object. When an object is tossed into the air, it tends to follow a parabolic path on its way back to the starting height. So basically, if you threw a ball into the air, it goes up, kind of curves over, and comes back down, which looks like an upside down parabola. So the most common quadratic formula that are used in word problems is this one. The height at any given time is negative 16 times the time squared plus the velocity at times the time plus the height at 0, plus when it started, okay? So it looks really scary, but it's really not. So this formula just calculates the height of an object that's thrown into the air or dropped off a cliff or a building or thrown out of a tree. So just you throw it in the air at a certain velocity, and at any given time, 3 seconds from now, half a second from now, how high is it in the air? Alright, so v sub 0 is the velocity that it's thrown, and h sub 0 is the starting height. So if you were standing on a stool and you tossed an object into the air when it was 8 feet above the ground, so as it left your hand it was 8 feet above the ground, you tossed it up at a velocity of 39 feet per second, you're going to fill in 8 for the starting height, 36, it should have been 39, 39 for your velocity, that's 39 feet per second. And your negative 16t squared, that's all there. And then you can graph it because now that's just a quadratic equation. Alright, so you can find the vertex, you can find the axis of symmetry, you can graph it and look at the path that the object took. So you can also plug in a bunch of different values into the equation for a time and find out how high the object was at that time. You may be given this formula and asked to find at the highest point, which is just a matter of finding the vertex. And you may be asked if the object was increasing or decreasing in height over a particular interval. And then this is just a matter of finding out if the slope is positive or negative. So is the rate of change a positive number? Is it increasing, or is it a negative number and it's decreasing? And it's all a matter of finding the characteristics of the functions and answering the questions about what those characteristics mean. So if we had a graph, alright, and we were asked to find this, alright, I would go to my calculator and plug in that formula. So we're going to go, see if I can do this in the video, we're going to turn the calculator on and go to our table function, and I'm going to plug in my problem, which was negative 16. Obviously I don't have t, so I'm going to have to use x squared, okay? That was plus 39x plus 8. Whoa. Squared, hit over, you got to make sure you hit over, plus 39x plus 8. Alright, so you keep hitting enter, and then you have these values. So at negative 1, it was at negative 47. So somewhere way down here on the graph. At 0, it was at positive 8. So I'm going to make these 5, 10, 15, 20, 25, 30, 35, 40. Alright, so at 0 is at positive 8. At 1, it was at 31. At 2, it was at 22. Scroll on down. And then by 3, it was at negative 19. So it went up really fast and came down really fast. So the graph looks something like this. So really, these negative numbers don't even matter because you can't have a negative amount of time. We could figure out the vertex of this, alright, by putting it into vertex form, and it would be a decimal. It would be somewhere up in this range probably. And that vertex would tell us its highest point, and we could figure out what the x value is of that vertex and figure out, okay, how many seconds had passed before it was at its highest point, and it's going to be 1 and some change. We can say it was increasing in the first second, and then after the second it was definitely decreasing. This part of the graph really doesn't matter at all. We can figure out at what x value Okay, at what x value was it back at 0? So at how much time passed before it was back at 0? So there's lots of different pieces of information that we can pull out of this function.